Alright, so these are the notes on conservation of momentum, which if you set up your notes like we had in class for that first part, then this would be the back. So this is like the LOCOM square. Okay. Also, for the vocabulary portion of your notes, conservation was one of the words. All right. Conservation really just means we can't create, we can't destroy. All we can do is rearrange. Okay. With my visual right here, I have a really big fish and I have a little fish. And then the big fish eats the little fish. Okay, so he has a certain speed and the little fish didn't have a speed. But when they go off together, the bigger fish now has to be going slower because he has more mass. But overall, the whole momentum has to stay the same, regardless. Okay, so really conservation of momentum is that the total momentum in a system remains the same if no external forces act on them. Okay, so all the momentum that you have at the beginning has to equal all the momentum you have at the end. And that's why I have these little epsilon p's, because that epsilon means summation. So the sum of all the momentums in the system before a collision has to equal all the momentums of after of the objects. All right. So we have the words elastic and inelastic in our vocabulary list as well. Elastic, when you think about it, most of you think about like a rubber band and stretching it and it bouncing back. Okay. Really, for the elastic, I want you to put the words bouncing back as your definition, or bounce apart even. You could say bounce apart. And then for inelastic, I want you to write the word sticks together. For inelastic, I want you to write sticks together. Now in our notes, we have specific sections for elastic and inelastic. So you can write these formulas, or you could write it with the law of conservation and momentum section. It can go in any part of it, all right? But the top part is elastic, and elastic is where you have a collision in which the objects collide and bounce apart with no energy loss. This formula is on your formula chart, and it has it as the mass and the velocity of 1 plus the mass and velocity of 2, then equal the mass and velocity prime of 1 and the mass and velocity prime of 2. Really, that prime symbol just means that it's a different velocity after than it is before. If you look at your formula charts that y'all have gotten from me, it says like I and F. And I'm like, that gets too crazy because there's a lot of letters going on already in numbers. So that's kind of why I like the little like apostrophe sign, which is known as the prime sign, instead. Okay? Then for inelastic collisions, this is a collision in which the objects collide and some mechanical energy is transformed into heat energy, which typically means they're going to probably stick together in some way. So the formula could be rearranged, and it could say, you know, the momentum of object 1 plus the momentum of object 2 has to equal the masses combined after the collision and a single velocity, because they're going the same velocity. Now the thing to realize is this particular equation can be read both ways. Okay? And the reason I say that is because they could start together and then break apart. And that momentum would be reading it from right to left versus left to right. A way to think about that would be kind of like if I have a firework starts as a single unit, and then it goes up as a total mass, but then it breaks into all these different parts. all those different parts and their velocities added together has to equal what it originally started with, that momentum. So that would be reading it from right to left versus from left to right. Okay. On this top part, a good example would be like pool. Okay, for an elastic collision, when you shoot pool, okay, the cue ball and all the other balls on the table never stick together. They always bounce apart. So that would be a good example of an elastic collision, would be playing pool, whereas inelastic would be like a firework. Okay? So with the animation here, we have inelastic because they stick together. All right? But notice I have 20,000 units of momentum, but then afterwards I have 5 and 15 because it's 20,000 and 0. So it's 20,000 overall. Afterwards it's 15 and 5, which is 20,000 overall. So ultimately it has to be conserved. Okay. Then this one's elastic because they bounce apart from each other. But this one has 60,000 and this has 0. So the total is 60 before they hit. This one decreases to 30,000 after they hit. And this one increases to 30,000, which together is still 60,000. So the before and after sums always have to be the same. That's the rule for the law of conservation of momentum. Okay, and this is the same one. So this one, same thing. I start off with 40,000 and 0. They do stick together, so it's an inelastic collision and move off with a single value. Notice their velocities are the same after they have collided. They both have 4, and that's why it's inelastic, because that single V value is after the equal sign. And this 32,000 and this 8,000 add up to 40, which we originally had. Okay, so here I had an example. And I will tell you the key thing about these problems is to primarily make sure that you do your, figure out whether it's elastic or inelastic first. Okay, so this one I have a hockey puck and a goalie. And I really need y'all to kind of think about what's really going on, all right? And the puck is going to be moving at 48 meters per second and it's caught by the goalie. So if the goalie catches the puck, then they're on ice. After they collide, do they move separately or together? So you have the puck individually and you have the goalie individually. And the puck comes in, the goalie catches it, and then they move. Do they move together or do they move separately? They move together. So because they move together, that would be that this is inelastic. So if you're putting this in your notes, you might want to put this example in your inelastic section. Okay, so we have our, I like to also write down always what my objects are. So I'm going to say that object 1 is going to be my puck, and object 2 is going to be my goalie, just to keep things separated. Okay, so since we said it was inelastic, did they start apart or together automatically? They started apart, so we would do our M1 V1 plus M2 V2 equals M1 plus M2 V, because they ended up together. So we know our object 1 we said was our puck, so it's 0.105 kilograms. And we know our object 2 is our goalie, who is 75 kilograms. And we know our V1 was our hockey puck, so that was 48 meters per second. And the goalie is at rest, so our V2 before the collision is 0. Now I always like to draw a line right here, right about my equal sign, and then write my other information. So I'm trying to find my V value. My M's are going to stay the same, so I don't necessarily need to rewrite those. Okay, does that make sense? All right, so now I'm going to plug it in. So I have 0.105 kilograms multiplied by 48 meters per second. And then I'm going to add that to 75 kilograms times 0, which is actually just going to be 0, equals 75 kilograms. Let me write that in the correct order. That would be, this is 0.105 kilograms plus 75 kilograms, all multiplied by V. So then with my calculator, okay, with your calculator, you end up multiplying those two and you get 5.04 kilograms meters per second plus 0. And then when you add those together, you get 75.105. So then you divide by the 75.105 on both sides to get V by itself. That cancels out your kilograms. So then when you divide 75.105, you end up with an answer of 0.067 meters per second as your V value. Okay? So really, like I said, when you do these types of problems, you really should just, one, figure out whether it's inelastic or elastic, then identify each of your objects so you can keep things separated, then write the formula of the inelastic or elastic, then identify all your variables just like we normally would do, and then you'd have your variables formula, then show your work, have your answer and your units, just like we normally do for our FWAU. Okay? All right. This next one. Didn't make sure my stuff was erased before I got started. Okay. So I have a 0.5 kilogram ball traveling at 6 meters per second. It's going to collide head on with a 1 kilogram ball that's moving in the opposite direction at a velocity of a negative 12 meters per second. Now the reason that that negative 12 is there is because of the fact that it is traveling in the opposite direction. So that's how we tell that the velocities are going different ways, is by making one of them negative. Okay? So the 0.5 kilogram ball moves away at negative 14 meters per second. So it's actually changed directions because it started off at 6 meters per second one way, and then it changed directions and now it's going negative 14 meters per second. So you can kind of think about it like going right and left, and that positive's right and negative's left. So this was the 0.5 kilogram ball, which I'm just going to go ahead and identify as ball 1. Okay, it was traveling right, but later it's traveling left after the collision. So it's traveling right and then it's traveling left. And then the number 2 ball, okay, it's traveling left already, and then we're being asked to find the velocity after. Okay, so since they're balls, and this is kind of like pool is a way to think about it, okay, would it be an elastic or inelastic? Okay, do they stick together or do they bounce apart? It's bounce apart, so it's elastic. Okay. And when we identify our variables, they would look something like this. We would say that M1 is 0.5 kilograms and V1 is 6 meters per second. Then M2 would be 1 kilogram and V2 would be the negative 12 meters per second. Now this is my after information, but because I am saying that it is inelastic, or excuse me, elastic, not inelastic, because it's elastic and it bounces apart, then really it's just our M1V1 plus M2V2 equals M1V1, and this is where I have F's written here, but as I showed y'all earlier, I put primes. They're the same thing. It's really just a personal preference of what you want to write, okay? So we're trying to find this value right here. It's our unknown, okay? So we're trying to find that. So we're trying to find the V2 prime. So we could plug in all our numbers. And when we do that, it looks something like this. So we have our 0.5 times 6 plus our 1 times negative 12 equals 0.5 times negative 14 plus 1 times V2 prime. So really when you do your math, this becomes, I believe, 3 kilograms meters per second plus a negative 12 kilograms meters per second equals a negative 7 kilograms meters per second plus, and this is a V2 prime times kg. So then you need to simplify. So now we have a negative 9. And then we need to add 7 to both sides to get rid of it. So plus 7 equals our V2 prime. And then that's really just 1 kg still. So now we're at a negative 2. And that is kilograms meters per second divided by a kilogram, which would make our V2 prime be a negative 2 meters per second. Does that make sense? Again, I was just showing you the work here, but you don't have to do all of this. Okay? You do have to show me the, plugged in numbers, but you don't have to show me all that manipulation if you don't want to. Okay? Or all of it worked out that way. So, it is a negative 2 meters per second as your answer. All right, when you calculate it out. All right, let me go back one and pause. All right, so I have a 3,000 kilogram truck moving to the right with a speed of 5 meters per second. It's going to collide head on with a 1,000 kilogram car that's moving to the left with a speed of 10 meters per second. So there's some keywords here about right and left that you need to pay attention to because I didn't put signs in this one, okay? Then the two vehicles stick together. That's another important piece of this. So, and then they move at the same speed after the collision. So again, determine that post-collision velocity of them combined. So, first thing, is it elastic or inelastic? It's inelastic. Okay. And so we know the formula for that to be M1V1 plus M2V2 equals M1 plus M2V. So I'm going to identify my truck as object 1 and my car as object 2. So then as I do M1 equals 3,000 kilograms and its original velocity, I'm going to make right positive, so I'm going to say a positive 5 meters per second. And then my M2 is the car, so it is 1,000 kilograms. But the V2 is going to be a negative 10 meters per second because it's moving to the left. Okay, then I'm just looking for my V value of them combined. Their masses don't change, they just stick together. So then I'd have my 3,000 kilograms times my 5 meters per second plus my 1,000 kilograms times my negative 10 meters per second equals, and that would be my 3,000 plus my 1,000, which would be 4,000 kilograms V. So then if I did my math, this is 15,000 plus a negative 10,000 equals 4,000 V. So then I have 5,000 because 15 minus 10,000, 15,000 minus 10,000 is 5,000 divided by 4,000 equals V, which would give me something like 1.2 2 something, I think. Oh, not enough zeros to see. Yeah, 1.25. And that's meters per second. Now, if I'm talking about the velocity and I said that right was positive and I wanted to know what direction is this going, this is going to the right as well because it's a positive value once I solve for it. Okay? Alright. Alright. And I believe that actually is all of these notes. I did some additional, like, just practice problems in class, but your homework problems are exactly like this in part 2 of the homework page, which is posted. And so, again, identify them as whether they bounce apart or stick together first. Then identify your objects, 1 and 2. And then start assigning the velocities and then plugging it into the equation. And then it's algebra from there. Okay? All right. If you have questions, let me know.